Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray and in this video we'll be looking at composite functions. So let's get started. So let's start with composite functions. Let me define a function g from the set A to set B such that g of x is equal to y, where x is an element of A and y is an element of set B. Then I define a function f from set B to set C such that f of y is equal to z, where y is an element of B and z is an element of C. Then I define the composite function FOG. FOG. We are going from F to G. Now this function is defined only when the domain of f and the codomain of g are same. Only then can we define this function. It will be defined from the set A to the set C such that FOG of x is equal to f of g of x, which is equal to f of y, which is equal to z, where x is an element of A and z is an element of C. Visually, let's see what is happening. This is set A, this is set B, and this is set C. Then under the function g, x is related to y, and under the function f, y is related to z. Then under the composite function FOG, x is directly related to z under the function FOG. So the composite function is directly relating the first set to the third set and the elements of the first set to the elements of the third set. For example, suppose this is the set of students in a classroom, this is the set of their roll numbers, and this is the set of their marks in an exam. Then suppose student A, B, C is related to the number 001 under the function g, and under the function f, 001 roll number is related to the marks that roll number got. So under the function FOG, the student will be directly related to the marks that he or she got in the exam. So we are removing the set in middle by directly connecting the first set to the third set using the composite function. Now function f is defined from function f is defined from B to C, and function g is defined from A to B. If I define g of f, then as I told you, the domain of g should be equal to the domain of f, and since it is not equal here, so g of f is not defined in this case. But it may be defined in a separate case where the sets are different. So it may be or it may not be defined. For example, if I am defining a set function g from set R to R and a function f from R to R, in this case FOG will be defined since the domain of f is equal to the codomain of G. So f of G is defined. And if I try to define G of F, then again the domain of G is equal to the codomain of F. Therefore, G of F is also defined in this case. But even when both of them are defined, they may not be equal. Even when both of them defined, it doesn't mean that they both will be equal. For example, I'm defining a function f from R to R such that f of x is equal to x square, x and y belong to R, and a function g from R to R such that g of x is equal to 3x, where x and y belong to R. Now see that I am using x at both places, but this x and this x are not the same. They are different. They are in different functions. Now if I define G of F, the domain of G and the codomain of F are same, so we can define the function G of F from R to R such that G of F of x is equal to G of F of x, which is equal to G of x square, which is equal to 3x square. And if I define a function f of g, now for f of g, we see that the domain of f and the codomain of g are equal, so we can define f of g from R to R such that f of g of x is equal to f of g of x, which is equal to f of 3x, which is actually equal to 3x whole square, which is 9x square. So we see that even when both G of F and f of g are defined, both of them are different. So in general, f of g is not equal to G of F. They might be equal in some cases, but in general they are not. Okay, so let's take an example. Example, f of x is equal to x square plus 1 and g of x is equal to 3 minus x. Then find f of g of x and g of f of x. So first we find f of g of x. This is equal to f of g of x. So equal to f of 3 minus x. Now this means that I will replace x everywhere in the function by 3 minus x. That means this is equal to 3 minus x whole square plus 1, which is equal to 9 plus x square minus 6x plus 1. So this gives us x square minus 6x plus 10. This is our function f of g of x. Now g of f of x, this is equal to g of f of x, which is g of x square plus 1. So we will replace x everywhere in g of x by x square plus 1. This means 3 minus x square plus 1, which is equal to minus x square. 3 minus 1 is plus 2. This is our G of f of x. Second part. Now find the values of x for which G of f of x is equal to f of x. That means that 2 minus x square is equal to x square plus 1. This means that x square is equal to 1. That means x is equal to, now taking square root on both the sides, remember that whenever we take square root, we will put a plus minus sign on the number. We will put a plus minus sign. Do not just take the positive value, that would be wrong. So that means that x can take the values +1 and -1. This is our solution. Okay guys, so I hope you liked the videos. We covered composite functions in this video. If you did like the video, hit the like button and subscribe to our channel for more great videos like this. I'm Maitray Agrawal and thank you.